Hello, everyone. Recently, Amazon announced a new framework for building production ready AI agents called Strands agents. And I've been receiving a lot of questions regarding Strands, so I figured I'd record a short video demonstrating how to build a Strands agent and that can perform tasks, allow for creating custom tools, and leverage some of the built in tools that are available. Also, do things like multi agent coordination, etc. So, this notebook assumes that you have the AWS CLI installed and also have a Python virtual environment configured. And, um, and obviously, you can use this notebook in Visual Studio Code, SageMaker, etc. Okay, so let's jump right in. In terms of installation and setup, first let's get Strands installed. It's pretty simple. It's just two Python packages. Strands agent is the core SDK, and Strands agent's tools gives us the access to the pre-built tools like calculator, the file operations, web requests, and numerous others. So, tools are the superpower for your AI agents. They allow your agents to perform integrations with third party systems and other complex tasks. Okay, so let's create our first agent. In this cell, we create our first agent, which is 3 lines of code. We essentially import the agent class, we instantiate it, and send it a query. The agent's just performing a zero shot prompting task at the moment, but we have a working agent. And I know what you're thinking at this point is how did the agent know what model to use and what's happening under the hood? So let's turn on debug level logging to get those details initially and query the agent again. Okay, so when we run the agent and it's being initialized, we see that it uses a model ID of Claude Sonnet 4. So if you don't specify a model, this is the model that the Strands agent is defaulted to. Now, you don't have to turn on debugging to see what model is being used. You can also query the model parameters that the agent was using by simply getting the agent.model.config parameter value. And there you have it. Okay. So let's say we want to use an alternate model. Aside from the default Claude for Sonnet model, we just specify the string of the model ID. Now it's important to note that the Strands model is model and provider agnostic. You're able to use other providers like OpenAI, Google, etc. And the models don't have to be Bedrock hosted. If you want to use alternate CSPs, or if you're doing this from your local laptop and maybe want to connect to a local model, you can use the Light LLM unified interface to connect to the other providers. Strands has that capability built in, or Olama or other classes are available to allow you to do that. Okay, so let's do a quick query to confirm that our model change from Sonnet to Haiku occurred. So we're just going to prompt it with, "Hi, what's your name?" And now you see that the model ID is Anthropic Claude. So now you're probably asking me, well, where do I define my region and inference parameters related to the model? So if you want more control, you can define your model using the Bedrock model class and define the inference parameters and the region information. So again, if you wanted to use other cloud service providers, hosted models, or local light LLM, the light LLM class within the Strands model is an option for you. But for now, we're just going to use Bedrock. And you see I defined a region and the temperature. And we go ahead and configure it. Okay. So creating a custom tool. So here's where things get really interesting. Is what makes an agent is its ability to call an external process function or API known as a tool and bring that back into the model's context. So here we define a custom tool that takes in two string parameters, name and language, and generates a personalized greeting. Defining a custom tool is pretty easy, uh, and you place a tool decorator above the custom tool, and you define a doc string within the tool describing what the tool does. You also need to define type hints for the input variables that you're taking in. So for example, name is of type string, language is of type string, and we're expecting a string output here. And now we can invoke this function a couple of different ways. So I just want to turn off the debug level logging so it's easier to view, and we did that. And essentially what this function does, it creates a personalized greeting based on the name and the language passed to it. So I am defining the tool. But now I'm going to use a natural language invocation, and the agent decides which tool to use. And also it essentially parses the information and sends the information like my name and the language I want the greeting in to the tool dynamically. So here you see it. The personalized greeting for Noel is "Hola, ¿cómo estás?" Okay, and so we can also invoke this custom tool with direct invocation by specifying the actual name and the language variable directly to greet the user. And you might want to do this in cases of maybe you have a Pydantic object coming from an external source that you want to invoke it that way, etc. You certainly can. Okay, so Strands also comes with several pre-built tools that you have access to once you install the Strands Agents tool package. Let's see how to use these built-in tools. So I'm going to turn off the debug logging again. I believe it was turned off earlier, but just to essentially confirm that it's turned off. And now I leverage the built-in tool. I simply import the tool and define it in my agent definition as a list here. So I'm using the calculator tool. And I use the same Bedrock model definition from earlier. And from here, I'm asking the agent, what is 25 times 47? It's going to know this is a math equation. It's going to know, understand the tool that is available to it, and it's going to print the result. Okay, and there you have it, and it gives you the response. All right, so now you're probably asking, well, Noel, if I use LangGraph, I can define a graph execution workflow where my functions are defined as nodes and the workflow sequences are defined as edges. Can Strands support this pattern? And the answer is yes. And here's how we essentially define our agent. And notice we're passing in built-in tools into the agent in the form of a schema. So here we create the graph and we're defining the tools as nodes and the edges of the sequence of events to occur. So now if we were to invoke our agent, and we're essentially creating the graph now, and you see the graphs created, and now we can confirm that it properly created by prompting the agent to list the available graphs. And you see that the available graphs, it says that the action parameter to listing, the command returned a list of all the available graph tools. We just called our graph, okay? And from here, we pass it the query. So we're saying use the graph tool with these parameters. So I want to execute a graph with the graph idea code pipeline, which if you notice, we defined above here, okay? And I'm essentially telling it to create a Python function that generates a Fibonacci sequence up to n terms, then call it with n equals 10 and print the results. Basic programming task we all were probably interviewed on at some point. And let's execute it. So when we invoke the agent, we see that the agent generates the code, and then it uses the Python REPL tool to actually run the code and show us that it executed successfully. It defines the steps and list the output. Now, we could have had a shorter prompt here. I wanted it to be more detailed to actually define what's going on here. Okay, the final thing I wanted to show is human in the loop. And this is an important feature when we implement an AI agents, because there's going to be times we want human approval or input before proceeding with the sequence of steps. And we're going to be using three built-in tools here and for this demonstration. And the human in the loop tool, which is known as handoff to user, the shell tool, which allows us to work within a command line shell, and the file write tool, which we use to essentially create files, is what we're going to use. And I'm going to use my command line to do this because it requires input, and I want to make sure that I am able to type in the input. So I'm literally just going to say Python human in loop and run that py file. Let's expand this. So it says I prompted it with I need to delete an old file named test.log. I gave it the location and create a new file named new test.log located in the same directory. And I'm also specifying what content that I want to be contained in the new file. Okay, so it's basically saying I want to confirm these steps before proceeding so we don't accidentally delete or overwrite anything important. So I want it to proceed, so I'm just saying yes. And it's confirming the action, so it's going to write the file. It's going call the shell tool. It deleted it and it created the new file. Okay, so now let's make sure that it created the new file, and you see it absolutely did according to the current time. And now if I just view the new file, you see that it has the content in there that I wanted specified. Okay, so this concludes this short demo. I hope you enjoyed this short video. I'll provide you this notebook in my GitHub, and I encourage you to download Strands, experiment with AI agents, and happy coding.